Hi everyone. Today we're going to be talking about COVID-19. There's been a lot of media coverage about COVID, and it sort of desensitized us to just how big this pandemic has been. So I decided to compare it to some more well-known events. Each block represents 10,000 American deaths. As you can see, COVID-19 has already surpassed the total deaths from car accidents in the 2010s, and it is quickly approaching the deaths from World War II. However, it's also important to note just how long each of these events took. Car accidents in the 2010s is, of course, a decade, and World War II lasted 6 years. But COVID 19 has only been around for 10 months, and cases aren't slowing down. In fact, cases are higher than ever before, and thousands of Americans are dying every day. So, how can this pandemic ever come to an end? Hi, my name's Justin Sinajad. I'm a chemical engineering junior at the University of Connecticut, and I'm going to be talking today about vaccines. Just as a disclaimer, I am not a doctor. I am an undergraduate chemical engineer, but all my sources that I used will be cited in the description, and I also had a biologist with a PhD in immunology look over it. So we're going to start off today by talking about the history of vaccines, and then go into how they work, then finally cap it off with some safety concerns from the clinical trials. So first off with the history of vaccines. Vaccines have been used to eradicate some pretty nasty diseases, and I'm going to list some of the major ones. Just a warning that some of these images may be a little bit disturbing, and they may give you the creepy crawlies, but it's important to know what humans had to live with just 100 years ago. So the first vaccine was in 1798 for smallpox, which is famous for killing an estimated 20 million Native Americans when Europeans first colonized the region. Rabies is known for its victims experiencing excessive salivation and high aggression, and having a near 100% fatality rate if the victim is unvaccinated. Pertussis, also known as whooping cough, is less deadly than the previous two, but it can lead to fatigue, vomiting, and difficulty breathing. Yellow fever, also known as jaundice, is easily spotted due to the discoloration of the skin caused by liver failure. Mild strains lead to a fever and vomiting, while the severe strains have a fatality rate near 50%. Polio also has mild and severe strains. Mild symptoms include fever and muscle stiffness, while severe symptoms include loss of reflexes and loose or floppy limbs. I don't know about you, but I personally haven't had any of these horrible diseases or know anyone that's had any of them. And that's something I can think due to vaccines. And you may be thinking, oh, maybe they just went away naturally with time. But that's not really the case. But let's look at an example a little bit more closely to really emphasize that point. Measles is something that I personally never had to deal with, but it was really prevalent back in the day. Just how many annual cases of measles do you think happened from 1950 to 1963 in America? Take a second to pause the video, or just guess. So yeah, 503,000 cases of measles every year in the US. It's absurd. 19 out of 20 Americans had contracted measles by the age of 15. And this wasn't a pretty disease. It caused a lot of really intense itches and sent around 50,000 people to the hospital every year and caused nearly 500 deaths annually. And while the data only goes up until 1950, this disease had been around since the 11th century and it wasn't ever going away. But as you can see on this graph, it takes a sharp decline around 1963 or so. And you may be wondering, that's weird, I wonder what happened. So, turns out the vaccine was introduced in 1963, and ever since then there's been a sharp decrease in the number of cases. Many people don't really understand just how effective and life-saving these vaccines can be, and I think this graph does a really good job illustrating that. So now that we've understood the history of vaccines, how exactly do they work? Before we understand how vaccines work, we first must understand how viruses work and also how ribosomes work. Ribosomes are tiny organelles inside of our body, and we have about 1 million of them per cell. They're the builders of the cell, and they make all the proteins around us, and they'll be represented by the builders on the left. How they work is they take some genetic material from the nucleus, and they go read it. And then they'll go build a protein using that information. That protein can be used for some random function inside the body. However, while they're really good builders, they're not very smart. So if a virus is able to enter the cell, it can send some of its genetic material, and the ribosomes will still read that, and then go print some more viruses. There's virtually no way for us to stop the virus once it's entered the cell, because it's so good at tricking the ribosomes. So we must focus on finding ways to stop the virus from entering the cell in the first place. COVID-19 and other coronaviruses use what's known as a spike protein to enter cells. Spike proteins are those things on the outside, and in this graphical representation, they're shown in red. Fun fact, under a microscope, these spike proteins look like little crowns, and the Latin word for crown is corona, which is how this class of viruses got their name. How the spike protein works is it basically acts as a key to unlock the cells. So as the COVID-19 wanders around, it may encounter an ACE2 receptor, and that spike protein can basically act as a key to unlock the cell and allow the virus to send its genetic material and replicate. This is really bad, and scientists are trying to find ways to stop and hinder this spike protein from allowing the virus to enter cells. But how can we do that? The short answer is vaccines, but how exactly do they work? One thing that's important to note is that vaccines do not actively kill the virus inside of us. They merely just teach the body how to fight it. So one analogy that I think is really important to understand is, let's say you're playing a Mario game, and this is your first time playing, and you can't respawn. You only have one life. Otherwise, you have to go buy the game again. And let's say you encounter this blue magical turtle that's covered in spikes. You might be able to beat this the first time, but if you, say, handed this to an older relative, they might not be able to complete it. And because they only have one chance, you don't want them to go fight this boss without some proper training. So you don't want them to train against this. You want them to train against a much weaker version of it, let's say a Koopa. But because your older relative is not as experienced, you also want to give them as many advantages as possible. So maybe you're even going to blindfold the Koopa, or maybe even cover him in bubble wrap. And that way, they can fight and train against this weakened state, and eventually learn the winning strategy. And that winning strategy is to jump on the Koopa's head. So that way, when they encounter the real magic blue turtle, they can go do that same winning strategy and find a way to beat the boss. Relating this back to vaccines, you do not want to blindly fight the boss battle. You first must train on a weaker version of them. For Mario, he learns the winning strategy is to jump on the turtle's head. For our immune system, it learns the winning strategy is to target the spike protein using antibodies so the virus can no longer enter our cells. While this method is proven to be effective, it is very difficult to find Koopas that are blindfolded and covered in bubble wrap, and likewise very difficult to find and grow this weakened version of the virus, especially considering we need enough doses for 7 billion people. So what's another solution? mRNA vaccines do not use weakened versions of the virus. Instead, they train using a virus costume. Let's say Mario wanted to train to fight the magic turtle, but couldn't find any Koopas around. He decides to ask his brother Luigi to put on a Koopa costume. Mario can then train until he has developed that same winning strategy of jumping on the turtle's head. The mRNA vaccine works by giving some genetic instructions to the ribosomes. The ribosomes then construct a spike protein. This spike protein sits on the cell membrane and is used to train our immune system. If our body encounters COVID-19, our immune system will be able to identify and eliminate it. Many vaccines require 2 doses, and you can think of this as extra training. However, we do not want to give more than 2 doses because it has diminishing returns and it's more important to vaccinate a larger population. Next, I'm going to play a clip from 60 Minutes for another way to visualize what is happening.
We've all seen pictures of the coronavirus with its crown of spike proteins. The mRNA vaccine instructs your healthy cells to make replicas of the spikes. They can't make you sick, but they do teach the immune system what the virus looks like. If the real virus shows up, your immune system antibodies will attack.
Next, we are going to address some safety concerns from the clinical trials. In order to ensure the vaccine is safe and effective for everyone, it must be tested on a large and diverse sample. We are going to look at Pfizer biotech data because that was the first vaccine to be approved. However, every other vaccine has similar data. This vaccine was used on an initial sample of 37,000 people, and there was about a 50-50 split for males and females. Additionally, there was a good distribution of ethnicities. While white and Hispanic/Latinx made up most of the sample, this is a good representation of U.S. American demographics, especially when you compare it to the 2019 U.S. Census estimates. Additionally, ages range from 16 to 89, and 35% of the participants had a BMI over 30, which qualifies for obesity. In order to test how effective the vaccine was in an ethical way, half the participants were given the vaccine and half were given the placebo, and they were told to live their lives normally. If the participant contracted COVID 19 for more than 7 days, it would be reported. Of the 18,000 people to be given the placebo, 162 of them contracted COVID 19 that lasted longer than 7 days. Of the 18,000 people given the vaccine, 8 contracted COVID 19 that lasted longer than 7 days. While these numbers may seem small, they are very significant. This was a double-blind study, meaning neither the participants nor the doctors knew if they received the vaccine or the placebo. Still, you were 20 times less likely to contract COVID 19 if you had the vaccine. Next, let's talk about the side effects. As mentioned before, 2 doses of the vaccine are given. Typically, the second dose had a higher likelihood of producing more severe immune responses, especially in people aged 16 to 55. About 50% of these people got mild to moderate headaches and fatigue after their second dose. Additionally, 16 of the people had a fever from 100 to 102, and 0.8% of people had a fever from 102 to 104. These seem bad, and they are much worse than most vaccines, but you have to remember that this is your body training to fight a very strong disease. Luckily, these symptoms resolved themselves within 2 days, and participants returned to full health. You may hear on the news that 2 people given the vaccine had died, and this is 100% true. However, you also must remember the age ranges of our sample. We had participants as old as 89 in this study. If you look at the causes of death, arteriosclerosis and cardiac arrest, these are seemingly unrelated to the vaccine. If you compare them to our placebo group, 4 of those people died there, all from causes more related to age than the vaccine. Thus, we can say that we are not too concerned about these 2 deaths and the safety of this vaccine. So what other things should we be concerned about? For one, this vaccine's only been studied for 8 months so far, so the long-term side effects are not too well known, nor is the length of the vaccine's effectiveness. However, these trials are still ongoing. Additionally, this mRNA vaccine uses similar mechanisms to one used in the past, with the only new thing being the coating of the mRNA so it doesn't break down in the body. Additionally, this vaccine has not been tested in children under 16 or in pregnant women. There has been no research into this thus far, but studies will begin shortly. Additionally, science is never really constant. It is constantly building off of itself. Certain statements made one day may be contradicted or disproven by other studies, which is what happened earlier in the pandemic with masks. However, as long as the initial study made logical sense and was good science, it should be safe, which I think is something that has been done for this vaccine. Next, let's address the misconception that this vaccine has been rushed. While it is true that this vaccine's creation and approval has been faster than any other, all necessary safety measures have been followed. Let's look at a timeline of the vaccine. On January 9th, the World Health Organization announced that they had detected a novel strain of a coronavirus, and on the 31st, they declared a global health emergency. On March 13th, many of us in the US went into lockdown. At this point, many companies had already begun developing vaccines. On April 29th, the vaccine began phase 1 trials, basically testing its safety on a small group of people. Getting to this point normally takes years, but companies were able to do this in weeks because of the unlimited resources and intense focus on solving this pandemic. After 3 months, the vaccine entered phase 2/3 clinical trials, which would normally take a year or two because it is normally difficult to find volunteers. On December 11th, the FDA approved the vaccine for emergency use only, such as this pandemic. It has not been approved yet and will be done so in the future. Additionally, it is important to note that we've had this vaccine since April 29th. It has not changed at all since. These companies first test this on a small group of people to make sure it is safe and effective, which it has proven to be thus far after 8 months. This vaccine has the potential to save millions of lives, restart the economy, and rebuild the world. Many are touting it as a miracle, but calling it such would discredit all of the hard work put in by the scientists who made it. This applies more than just to the scientists at Pfizer, but also the ones at Moderna or AstraZeneca, because no single company can manufacture 7 billion doses. This also applies to the healthcare workers who have been working non-stop to save countless lives. It also applies to the engineers who are obtaining raw materials and creating 7 billion doses to vaccinate the planet. It also applies to the computer scientists who are able to model the virus so biologists could develop this vaccine. This isn't an effort by a single company or a single field, but a joint effort by STEM workers across the planet in order to save the world. I'm not going to lie, these jobs are all difficult and require a great deal of effort and time, but they allow you to do some really amazing things and create a better tomorrow.